What do we have over here? Building an authorization server. That would be the natural progression after using GitHub for external authentication, which is an Auth server, and then delegating authorization from YouTube, which is also an Auth server. And in this video, we're going to build an authorization server. Reason being is generally, if you want to start doing external authentication or dealing out tokens, people will jump to Identity Server, OpenID Connect. You don't need all of that complexity. You can implement it yourself with relatively minimal effort, which is what I'm going to show you in this video. We'll also be using the auth specification as a reference, so in case you will get lost on your own, you will see me use it and hopefully you will know how to use it as well. My name is Anton, welcome to the Raw Coding YouTube channel. If you are enjoying this video, don't forget to leave a like, subscribe, click on the notification bell, and I'm also adding more merchandise to my store. Go ahead and check out a link in the description. If you want to be the first one to know about things that I'm doing, go join the Discord server. The link is in the description as well. Let's go ahead and get started. So we have a roughly intimidating looking setup over here, but we have a client that is going to be authenticating with our authentication server, which is an Auth server. The client is basically a copy of one of our previous projects where we have the cookie authentication and we want to externally authenticate with our Auth server. Hence, we're pointing to the authorization and the token endpoint. We still have like a custom callback over here. We will need to do a little bit of additional work. We are using PKCE, which is what we're going to be covering today. So if you don't know what PKCE or how to implement it, you're in luck. We then hit the login endpoint on here and initiate our external authentication. And that's all there is to this client over here. It runs on port 5004. Auth server runs on port 5005. The Auth server setup is a little bit more complicated, but nothing that you don't know already. We have cookie authentication with a login path. So when we hit this authorization endpoint, because we need to be authenticated, we're gonna go to this login page over here. The login page is pretty simple. We have our form without any user or password fields, so we're omitting all user management. We're focusing on auth. I'm retaining the return URL, and that's what we're gonna be passing further into the login endpoint, where we're just signing in and redirecting to the return URL. So that's the login and the get login endpoints. We then have the authorized and the token endpoints, which is up to us to implement. So they are both empty. To quickly reiterate over the auth flow, first of all, we're going to be on the client. We're going to click login. When we're going to land on authorize, we're not going to be logged in. We're going to go to the login page. We will then submit our form. We will process the login. We will get authenticated. We'll get redirected back to the authorized endpoint. We will create an authorization code, redirect back to the client, and then through the back channel, obtain a token by posting a form to the token endpoint. Now, a quick note on the dev key service that I have over here. It is basically a process of generating a key and then saving it in a file and then reloading it from that file. If you've watched my JWT video, you understand what I'm doing here. If not, then go ahead and watch it. So as the story goes, we want to be implementing the authorization endpoint first. And writing code will be the easy part. The hard part will be what code to write. And for this, we're going to refer to the auth specification. The first bits are really the introductions and the first section as well, where all of the terminology to you is explained. I'm not going to go over it. I'm going to mention it. If you really want to understand it, open this document up and read it. It's not the easiest read, but once you get it into your head, it's pretty good. The second section is client registration. If you've watched my previous video where we have to register a client with GitHub or YouTube, we fill out a form. This is that information. You get given a client identifier, a client secret, you specify where do you want to be redirected to, etc. Section 3 describes the information about which endpoints we want to implement, which we already basically have the groundwork for the authorization and the token endpoint. Not much information about the authorization endpoint, but it has some information about the token endpoint, which we're going to come back to later. Think of section 3.2 as the base class, and then we have the actual description of flows. How do you obtain a token? This is where supported flows are described. We're interested in the authorization code grant flow, where an access token is obtained through a backchannel on the server side. Whereas section 3.2 is the base class to the token endpoint, the token endpoint extension sections are implementations, where there is basically a composition between these two sections around what parts you want to implement. Let's jump straight into the authorization code. We're not going to go over the flow because I've already killed it to death. Here we have the authorization request. What kind of information do you need to supply? We have the response type, which describes what response are you going to get. We are asking for an authorization code flow because there is an authorization endpoint for many flows, and they will give you back different things. This is the way that you specify what result you're going to get based on which flow. You're essentially picking what flow you're choosing based on your response type. You have then additional information of which client is asking for this. You then have code challenge and code challenge method. This is part of the PKCE specification, which should be described in section 7.6, or at least reference to this PKCE RFC, which in section 4 and 4.2 describes how it's constructed. So we can reference this later when we're actually working with these two parameters. We then have redirect URI, scope, and state. All of this information is coming from the URL, and if I find it right over here, right, this is an example of a request to the authorized endpoint. And here we also have some information about how the code challenge is constructed, and then we have the code verifier. So if you're not familiar with PKCE, the client, before going over to the Auth server, will generate a code verifier. So the client is holding a code verifier, goes through this process of constructing a code challenge, sends that over to the authorization endpoint with the code challenge method, which is this SHA-256 encryption. On the authorization endpoint, we have to somehow persist this information because on the token endpoint, as we'll find out later, the code verifier is going to get given to us, and we will have to take the information that we received on the authorization endpoint, match it with the information we're receiving on the token endpoint, and mash it together, regenerate the values. And this gives us proof that where the request originated from is where the token is being obtained is the same place. So first of all, let's go ahead and get these parameters into our code. For this, I'm going to use the HTTP request. And on the request, we will have the query where I can try to get these values. We end up with something like this, essentially parameters to our functions. This is how these parameters are going to be supplied. And then we want to generate an authorization response. It has to consist out of the code, the state, which is being passed to us over here, and then the issuer, who is issuing this token. All we have to do is redirect back to the client on the callback path. The callback path is going to be found in the redirect URI, and we have to attach these parameters as a query string. Okay, not too complicated. Instead of returning OK, we will just redirect to where? To the redirect URI. We will have the code and then the other parameters as well. So the final result that we'll try to return will look like this. The main thing that we're trying to generate is the code. So what is the code? The code is described as an opaque value, which basically it's just something that shouldn't mean anything to anybody but the thing that is generating this value. It shouldn't last for a long time, and then it shouldn't be used more than once. If it is being used more than once, revoke all tokens that have been generated by this code. So we will need to persist this token in some kind of blacklist if it's been used, and if it's being used again, delete all the tokens. And again, you can revoke and delete tokens by using this blacklist database of tokens. And then that the authorization code is bound to the client identifier, code challenge, and redirect URI. If we scroll down a little bit, there is a bit here about authorization, and then there is a bit about the code challenge and code challenge method. They need to be linked to the authorization code, and this is because we're going to need that information at the token endpoint, because we will need to validate that that request is coming from the correct place. We will need to also validate this authorization code. The way that we're going to do it is we're not going to be storing it in the database because that is long. However, that would be the correct implementation. We're going to be using encryption and the data protection API. So data protection provider, let's get data protection provider over here, a little bit closer to where we're generating the result, because this is where your validation should occur. We want to create a protector for OAuth. This will be our protector. Here we will protect a payload. We want to protect an authorization code. This is where we can create a new model, class auth code. And inside of here, we will start putting information that should be associated with the authorization code. And there we have it, client ID, redirect URI, code challenge method, and the expiry. When we're creating our code, new auth code, this is where we populate these parameters. So here I have a code that expires in 5 minutes. All of the information that I store in there, I will now serialize this code, and then I'm going to encrypt it using the data protection API. This is going to be a code string, which I can then pass in the URL. And this is pretty much the backbone of the endpoint, which should work. The rest is edge case handling. What if this parameter is not supplied? What if the correct scope is not being requested? The rest is validation. Let's fire up our applications, Auth Server, .NET Watch, no hot reload. Same thing on the client side. We're gonna open up our client app and close the server. First of all, let's double check I don't have any cookies. I do have one. So I'll remove that, going over to the network tab, and please, if there is anything you take away, if you're working with authentication, auth, OpenID Connect, the network tab in the browser is your best friend. This is how you understand what the heck is going on. We're currently on the client. We want to log in. We type in login. We are now on the submission form. What the heck just happened? And please do notice I have preserve log on. First of all, we went to the login endpoint. We went there with a GET request, and we got a 302, and 302 just means that we got redirected to the location. In the response headers, we are going to get a location header. That is where we're going. We are going to the authentication server, auth server, to the auth endpoint that we have specified with all the parameters, client ID, the scopes that we're requesting, which are none, the response type, which is code, and the redirect URI, which is pretty much just the custom callback, with the code challenge generated because we have specified that we want to be using PKCE because Auth 2.1 requires PKCE. All of this information is here. Now, because we're not authorized, we got redirected over there, right? So we're over here trying to get this route. We're not authorized. Where do we go? We go to the login endpoint. We go to the login endpoint because this endpoint requires authorization. And we specify that if you're not authenticated with the cookie authentication, you go to the login endpoint. That is where we end up. We are currently on the login endpoint. So we got that. Okay. Here, if I quickly inspect the form, I am basically URL encoding all of the information for the return URL over here. I will submit, and now we get an error. It doesn't mean that anything bad has happened. Over here, we have posted our form. We've submitted our login information. We found the user, password's good, all good. You go back to where you came from. You go to the authorization endpoint with all of that good client ID, scope, response type information that you originally created. So this whole logging in story is just a side story. It's not the main story, right? We are just logging in just so we can reach this authorization endpoint. So we finally reached that authorization endpoint and it's successful. We get redirected back to the client, to the callback, where we're now trying to process this code that we have generated, right? Look at that code. It's beautiful. We also have the state and our issuer over here. We land on the callback, and the callback errors because why wouldn't it error? We don't have a token endpoint. So this is the next part. This is where we have to implement the token endpoint. And before we know what we need to implement, this is where we go over here. We will take a look at 3.2 first, which is the base implementation, and then 4.1.3, which is kind of like what's added on to the base. So what does the base implementation of the token endpoint say? it says that you're going to receive a client ID, you're going to receive a scope, which is optional, which is basically, again, for you to validate or for you to put things into the token to say which areas of your API the user has access to, right? Again, scope is about saying what resources a resource owner can access. What information can a user access? And here we have the grant type. Grant type, similar to the response type, is a way to basically select a strategy for the token endpoint. Many flows, you may get an authorization code, you may get something else. On the token endpoint, you may be processing authorization code, you may be processing something else. How you want to start? You specify the response type. On the token endpoint, what are you processing? You're processing a grant type, an authorization code that you specify in this parameter. These three are our base parameters, and they get posted to us as form URL encoded. So one thing, if you know about minimal APIs, is minimal APIs only allow posting JSON out of the box. So we're in a bit of a pickle, but nothing that we can't handle. So let's go over to our token endpoint, and again, start with the HTTP request. On the request, we're going to go straight to the body reader, get all of the bytes and UTF-8 decode them, and now we essentially have this payload over here. Because it's essentially a query string in the body, I could use regex. There might be a class that I'm not aware of that I can just put this into and it's going to automatically decipher the whole thing. I'm not aware of that other class, and I'm assuming most of you don't know regex. Regex is what I would rely on in this situation. I'm gonna do the, let's say, sillier thing. And we end up with this, let's call it parsing process. We split by the ampersand, we then split by the equals, we get the key value, and then based on the key, we assign the value to the correct place. A little bit monotonous, but it will work. Again, because this is the parsing process, this is where we would do validation of these values. And this is essentially the base layer to accepting a token request. You then have access token scopes. So again, you're loading permissions into the token. And then you have the response. This is what you have to return. You have to return an access token. You have to return what kind of type is it, when does it expire, the scopes that have been requested, and then a refresh token if it has been given. This is where, coming back to the application, we have already imported Microsoft Identity Model JSON Web Tokens package. If you've seen my JWT video, you're going to know what this package is. It allows us to work with tokens, and this is where the dev keys come in. This is where we're able to generate tokens, okay? So let's bring up our dev keys. On result OK, we will return a new result. We will specify an access token, and to create an access token, we will need a handler. New JSON Web Token handler. The handler will need to create a token, and in here we provide a security token descriptor. Here we can specify a bunch of claims. I'm giving it what is essentially a subject ID, user ID, and then a custom claim. Here I set an expiry time. The expires in is recommended. So if I would be supplying an expires in, those would be time span from minutes. And then we also need the token type. So token underscore type. This will be a bearer token. Okay, B. This can also be specified on here. Bearer. Scope and refresh tokens, I will omit. If you're wondering about refresh tokens, I will have a video on it later. Finally, to sign the tokens, we want signing credentials, which are going to be new signing credentials. And this is where from dev keys, we want to get the RSA security key. Security algorithms, I want RSA SHA-256. Okay, and that is what you do to generate the token. Now, this was the base thing for accepting and returning. There is a bit over here where the initial parameters only specify these three. However, I've also included the code verifier because this is where it is contained on the example response, and usually the extensions will show you that you need it. So coming back to the table of contents, we go to the implementation, to the extension of the base implementation here. The extension is over here, right? So token endpoint extension. Let's see, what do we want here? Code will be required. We already have the code. We then have the redirect URI that is required. That is over there as well. and then code verifier. So this is where we have the code verifier. I'm already getting it. This is again where they respecify the example request, and this section over here goes over what validation you need to perform, but mainly what we are going to focus on are these two sections. Verify that the code verifier parameter is present, and then verify the code verifier. In order to do this verification, we're gonna need to come back to where it is explaining what the code challenge is, which is the thing that we have originally stored into the code string, right? So here we have the auth code. So let's go ahead, get this code over here, go back to the token endpoint, place it over here, and we're not gonna be recreating the code, but rather using the data protection API to get all that information, right? Here is the code. We want to unpack it to get that code method. So data protection provider will create a protector, and here we want to unprotect. We're unprotecting the code. That will be the code string, and we want to use the JSON serializer to deserialize code string to the authorization code. Now, before we go too far, because this is essentially an authorization process and the backbone for the token endpoint has essentially been built, I just want to make sure that all the stuff that we're passing through here actually works. The debugger is attached. What I'm going to do is I'm just going to refresh the callback because there is no validation around any of the expiry time, if the code has been used more than once, etc. Or there seems to be some correlation checking, so basically cookies and stuff like that. Let's just re-log in. Here we are hitting the token endpoint. It went by pretty quickly, but here you can see we went to the login endpoint, we went to the authorize endpoint, and now we're coming back to the callback. On here, let's take a look at the auth code, and if that's been basically deserialized, everything is fine. So there is all of our information, and again, code challenge and code challenge method. The client is generating it. The auth handler is generating this information. And actually, we can go ahead and take this detour and see where it's happening. In the program CS over here, if we opening up the add auth, go to the add auth handler. And when we've taken a look at this before, exchange code async, this is where the exchange is happening. If context properties, and you may think it's getting stuff from context properties, didn't we put it in the options? Well, if you watched my previous video, you understand that the state parameter is used for persisting these properties and any other state information across that journey to the other side. This is where it extracts the code verifier, attaches it to these token request parameters, and this is where it's submitted through the back channel to our auth server. And this will be an interesting place to just have a breakpoint as well. Let's come back to the token endpoint. Let's take a look at some of the other stuff that we have. Grant type is authorization code. The code is the thing we already decoded. Redirect URI is the callback that we're currently on, and the code verifier is this secret value that is a little bit different from the code challenge that we're meant to reach. And again, let's just play this through, or actually just stop it. And we're just stopping the debugger. The way that we generate a code challenge, so again, the code challenge is on the auth code challenge over here. The way that we generate it is we need to take the code verifier, we need to SHA-256 it, and then base 64, and we're using ASCII encoding. And that is how we're gonna reach the code challenge. So again, let's create a function for it, right? We are good programmers. Private will validate code verifier. We're gonna have the auth code, and we're gonna have a string for code verifier. Here's our beautiful function. I'm gonna use a SHA-256 to create an instance for hashing. So SHA-256, and we can stick this in a using. This bit takes care of this SHA-256. And again, SHA-256 is a variable. This will vary depending on the code method or code challenge method that is being supplied here. And I'm only mentioning it because these are all the possibilities. In the chance that you need to comply with many different specifications, you will need to say that, okay, these Other services can parameterize my request, or you can say we're only supporting SHA-256, and if you supply an incorrect code challenge method, you can go, F yourself. Otherwise, if you're building this for yourself, most of this stuff you can expect it to be very linear. You don't need to cover an infinite amount of possibilities. So covering this SHA-256, we have the code verifier, and the way that we generate a hash SHA-256, we will have a compute hash function, which can get a byte array buffer. So we need to go to encoding ASCII characters and get bytes of the code verifier. This is going to give us some kind of value that we need to base64 URL encode. Now, there is a base64 URL encoder, and this is coming from the package that we have imported over here. I think there is another package as well, base64 URL text encoder, which is part of the ASP.NET Core framework. But yeah, we want one of the base64 URL encoders because it's going to vary in the characters that get put into the final result. So we want to encode whatever this thing that we're going to compute over here. This is going to give us a code challenge that has been regenerated, camel case. And finally, we can return code challenge equals this code challenge, place a breakpoint over here so we can take a look at it. And because the class is static, we want this function static as well. And right over here, if not validate code verifier, auth code verifier, right, we can return a results, not empty, but rather valid request. And there it is. So the application should reload, and let's reattach the debugger. And there we go. Now on the client side, let's remove everything. Let's re-log in. And before we log in, I'm just going to clear everything on here. Log in. Again, we're now on the token endpoint. We are inside the validate code verifier. And here what we're going to see is the code challenge looks like FBXGN, and this looks like FBXGN. So we have successfully taken our code verifier through the same encryption process and arrived at the same value. So whoever gave us this code challenge that is in our authentication code in the beginning is the same thing that is giving us this code verifier now. This is why we can say, okay, this is good to go. We can deal out our authentication token here. Let's remove this breakpoint over here as well, play. And I don't have a breakpoint on the other side, so we're not hitting this breakpoint over here. I don't even know who will need it. But coming back to the browser, no claims are displayed, although we should be authenticated. If I take a look in the application, we do have a cookie over here. And the reason we don't have any claims or no claims are displayed on Program.cs, this is where I've placed it to do. We still need to go through the process of mapping claims. At this point, we only have an access token. We're creating an identity because there is nothing that can enforce a standard of claims across all processes or all services that could possibly exist. It's a manual process, okay? If we know anything about access tokens, and I'm going to place a breakpoint over here, so we can actually inspect the access token that we're creating, we'll split it by the dot, and that will give us the base64 payload. Here, because we're in the client, we don't have that package. Here, again, try search for base64 URL text encoder. Here we can decode this payload. This will just be a payload JSON. We can now extract user or payload information. So payload JSON document out of this payload JSON, or sorry, rather this will have to get parsed. So parse. This finally can go into run claim actions payload, and this will contain a root element. Run claim actions on this context will execute whatever mappings we have supplied over here. So currently I am mapping a subclaim to a subclaim. So if on the token endpoint I'm supplying a custom claim with a value of foo, I will say that this custom claim I want to assign to custom 33 or something like that. So this claim type should now be in my user context and I should be able to see it. Let's make sure that both services are restarted and running. I'll attach the debugger to the client. I'll close the other debugger, and here we can re-log in. On the login page, let's submit. Here we have the response. In the body there, you should see the access token, and the response is 200 because we have an access token. Jump through to over here where the access token is a little bit more accessible. I'm going to take a look at the context and grab the access token. We can go to JWT.io, paste this in here, and we're going to see this middle bit is the bit that we're getting. So when we're splitting by dot, we're getting this middle payload bit, and this is the JSON object that is contained in there. Again, I'm plagued by the scrolly wheel not being inside of here, but the sub and custom claim is what we're after. Coming back to the application, I'm going to play this through, come back over here to the website, and we should see our custom claim be mapped to custom 33 and the sub claim also be mapped to the sub claim. At this point, we have successfully covered the green path, the backbone of the Auth flow. We have an Auth 2.1 compliant authorization server, or we're on the way there because you need a bunch of validation. What if you supply incorrect parameters, parameters are missing? You need to handle all of those edge cases. How do you do it? Well, the beautiful thing about specifications is that everything is already described here. If we go back to the table of contents and we go to the authorization request, that is where we're making the request, and we scroll down, there should be an error section. So 4121 error response. Basically, if anything goes wrong, this is the response that you need to return. Let's do a simple one where we will say an invalid request, missing a required parameter. Coming back to the code, going to the authorization endpoint, closing everything else and this window. So if a response type is not present, it's instantly a bad request. So we specify the error to be an invalid request because the request is missing required parameters, includes an invalid parameter value. So that's the error code that you put in the error property. Error description is optional, error URI is optional, state is required if it was present. So let's go ahead and actually just whack this at the top. I'll pass this on, and then we can also add the IAS value over here. Okay, or ISS, spelling it incorrectly, and placing this over here as well. So this would be a invalid request. Now, making sure that the application has restarted over here, coming back over here, going to that Auth server, to Auth Authorize Endpoint, and saying that the response type is whatever. Doesn't make sense. So first of all, we need to authenticate. Let's close this off, submit. And actually messed it up because there is no redirect URI. It looks like it actually skipped it because I actually have this parameter. Okay, so first of all, let's amend this a little bit. Let's just make sure that we supply no parameters. Okay, so no parameters, we get our invalid request, and now it's a proper error response. This is the way that you would handle all of these. Again, this code is pretty basic. There is no reusability here. This is pretty brute and can be implemented a lot more elegantly. However, you should get the idea about how to do your validation, where to find the codes, and what scenarios to cover. Because if you read this documentation from start to finish, you should understand what is required and what isn't. Ну вот и сказки конец. Тот, кто слушал, молодец. If you enjoyed this video, thank you very much for watching. Please don't forget to subscribe and click the notification bell if you did. If you have any questions, leave them in the comment section. If you want to say thank you, leave it in the comment section as well. But better yet, come support me on my Patreon, get the source code. Very big thank you to all of my patrons that are already supporting me. Your help is very much appreciated. Best of luck to you and have a good day.